When you think about pollution and environmental impact, a lot of times people think of smokestacks. You just look at the four walls around you. What if the building were made from recycled materials? Imagine the dramatically reduced hit on our natural resources. Think of the energy it takes to run our buildings, all of the appliances and lights in those buildings. If we can reduce that impact, that's one of the best things we can do for all the people we share this planet with. Green, high-performance buildings are important for one major reason: people. Healthy, productive employees, healthy, productive children.
It's not just the environment, it's the environment and economics. It makes business sense and it makes environmental sense. The Commonwealth has been a leader in the last years in developing green buildings and moving on energy efficiency. We can do more.
Every once in a while, we see a win, 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 and we grab it. It's a win for the environment, it's a win for the economy, and it's a win for our health, well-being, and happiness.
You don't just have environmentalists shaking their fist at industrialists anymore. The fact is, millions of Pennsylvanians care about the environment in their work lives, at home, in clubs, and in environmental groups, civic groups of all kinds. And we are piecing together new ways of building organizations and building physical things. That's what this building is really all about.
The state does not own this project. It's owned by a private developer. They solicited proposals from several developers for building, managing, owning the project, and leasing it back to the Department of Environmental Protection for 10 years with a 5-year lease option.
This particular site was actually a municipal dump. Then at 1972, the flood, which was Agnes, was dumped on the property and it was left. The Department of Environmental Protection and ourselves decided, what a great project. We'll build the building on a brownfield site.
The department felt pretty strongly that we have a commitment to reutilize brownfields wherever, however we can in point of how and where we're putting Commonwealth facilities. We've got abandoned industrial property just sitting there wasting away. It's really evolved into what we call our land recycling program.
Pennsylvania has enacted several laws to try to help future owners or lenders in owning degraded sites and developing them. Without the legislation in place in Pennsylvania, we could never develop sites like this because we could not withstand the liability issues. You could never finance a project.
In the mid-70s, it was closed before we had some of the regulations that we currently have, and basically has been sitting there since that period of time. So the developer designed and put together a leachate collection system. We also have a methane gas collection system that's been installed.
It was an extraordinarily difficult site. It was really tightly constrained. In fact, the program for the building, being that it was 73,000 square feet on no more than 3 floors, almost mandated the footprint size of the building.
It was probably about the time that we got through the brownfield piece of this that the secretary gave us a charge. And his charge was to make the building green.
We stopped a freight train, so to speak, and put the project on hold and assembled a green team to start looking into how we could do a model green building project.
It's a major decision that involves 3 individuals at least: the owner, the constructor, and the design professional. You have to get them to nod their head and say, yes, we'll try this.
When the decision was made to, hey, wait a minute, perhaps there's a more prudent approach in terms of sustainability of this building, this project took an entirely different approach, which is, I think, pretty much mandated by the green approach to building buildings, and that is that it's a highly integrated systems thinking approach.
Sitting down with engineers and architects and owners and manufacturers and the client all in the same room brings a very interesting perspective to how some of the decision making happens. Decisions aren't totally now made on, well, it cost us amount of money, therefore we can't do that. What's the right way to do it? What's the best way to do this from a green technology, from a sustainability, from an energy efficiency? And the reuse of things. I mean, we're using recycled steel in the building. Well, this makes all kinds of sense.
Today's electric arc furnaces are really scrap melters. A plant like this will use in excess of 90% of ferrous steel scrap. It's pretty much a continuous inline process. After that, we cut it to length and straighten it for the customer application. The technology has evolved to the point that we're able to grow our business by keeping the price of structural steel roughly equivalent to what it was 20 years ago in terms of real dollars.
With the green technology, the operating expenses through utility costs are significantly less, but that savings is realized over a period of time. In this situation, we don't believe anyone is more interested in the environment than DEP. We believe that they will stay in the building for a long period of time, and we also want to be associated with a building that is very environmentally friendly.
One of the things that I think we do in America is that we think of things in terms of being quite disposable. Hey, this building is like a Bic disposable lighter. We're done with it, we can throw it away. Well, I think we need to change that thinking and think more in terms of how long can we reuse this resource, which is a building which utilizes the resources which are in many ways not sustainable on our planet.
The new office is very well planned. It's modular workstations, it's modular furniture, everything is movable. We'll be able to do practically anything. I mean, we could reconfigure it 2 years from now if we need to, which we could never do in this building.
The building is very flexible, first of all. The green building portion of this building, the materials, the lack of VOCs, we are very friendly for whether it's DEP or another tenant. This building will lease before any other, I believe, in Harrisburg.
We tell the private sector to think smart about the environment, about energy savings, about efficiency and waste. When they do that, their costs are spread differently, but overall lower. That's what the taxpayers want us to do. That's what stockholders want companies to do. So Jim Toothaker figured out that the 2010 budget was going to be every bit as important to the taxpayers as the 1998 budget, and we figured out how to get there.
Well, right up front, the goal was to attempt to reduce the energy consumption for the building. Now, after the first oil crisis in America, we began making very tight buildings that didn't breathe very well, and suddenly a new problem emerged, the sick building syndrome. So what we wanted to do was to not simply tighten up the building and insulate it to death. We wanted to look at how we could make the occupants inside healthier, more productive, and more motivated.
The primary paradigm shift is that instead of supplying air from the ceiling through ductwork and diffusers, that the raised floor system, which creates the ability to run all of our electrical, voice, and data power to each of these workstations, also becomes a supply air plenum for the building.
Concrete itself, and many people don't realize this, will off-gas. It has some naturally occurring formaldehyde. It has, of course, dust. The penetrating water stop is designed to go in and react with the concrete and give it integrity. It has no volatile organic compounds in it. It has nothing which is going to off-gas and release into the air. And of course, That's very important in this particular situation because this is the air that's being circulated through the whole building. We use a computer model that was developed by the Lawrence Berkeley Laboratories called DOE2. The process that we followed was actually to identify what the baseline building was as defined by the DEP spec. When we ran the simulation, we came up with an annual energy cost of $1.54 per square foot.
Early on, they came to us and showed us their initial specification, which called for 100-foot candles throughout the entire office areas, which is excessive. So I came in initially in the project telling them they could reduce their lighting first cost for the system by over $40,000, plus reduce the energy cost significantly.
80% of the energy bill in a building in this region of the country is spent on cooling, not on heating. So when Marcus said, look, let's downsize the lighting here, let's not waste all those foot candles, if you will, he was also saying, let's not heat the air that you then have to run through an air conditioning system and buy kilowatt hours from your local utility company at higher rates.
The windows that are used in the project are 1-inch insulating glass, which means that there's an inch airspace between two sheets of glass, with a low emissivity, low E coating, which reflects back some of the solar radiation that would otherwise enter the space.
We really wanted to look at providing the most energy efficient source for the actual cooling that we're doing within the building. We began investigating gas absorption cooling technology. It has no compressors, it has no refrigerants. Environmentally, it's very benign type of technology.
The electricity consumption on an absorber is very low. Water is the refrigerant. There are no CFCs involved, HFCs or HCFCs in this type of chiller, and so it's got natural environmental characteristics associated with it.
The entire system of a building, or the integration of the HVAC mechanical system, along with the windows and the lighting and the materials in the space, all of these things are now looked at as an integrated working system, so that really all of the individual components, the air conditioning being one of them, changes dramatically as well.
For those of you that ever buy Japanese rice crackers and you find that little white bag in the package that says "do not eat," that's actually a desiccant material to absorb the moisture and keep the crackers crisp. So we're using desiccant air handling equipment.
The system that we have put together within our air conditioning box employs two wheels, and the first wheel being the device that has a desiccant material. And in essence, what happens is it does soak up the moisture on the one side of our system and rotates to a separate side of the system where we're able to exhaust the moisture away.
The outside air in the Susquehanna Valley is very humid in the summer. It blows across that wheel and all the moisture is absorbed out of the air, so that what you have is a very dry air that's coming in before it gets to the air conditioning equipment. So we've reduced approximately 25 tons of cooling by incorporating desiccant air handlers into the building.
I just got a letter.
The landlord has been extremely helpful in the cost containment parts of this. We have cut our energy consumption costs from $1.54 a square foot, which is where they were pegged on the original deal, to 74 cents a square foot. That's a major cutback, so we're pretty impressed with that.
You need to get those here.
Is there anything holding up Sponago from putting that line in?
Well, I was convinced that through the DOE2 model, which was done by Carnegie Mellon, that this building would be more efficient than any other building we had ever built.
The access floor system provides a ductwork for the air conditioning. The underfloor wiring for power and communications can be distributed with flexibility and accessibility. And it extends indefinitely the life of the building.
The access floor box system cut down on the amount of cable that must be thrown away. It
Because of its modularity and its flexibility, the same box can be used in different areas, and the modular inserts can be changed, so it's efficient use of materials, both the cabling and also of the box and its contents.
We install our diffusers into the raised access floor panels. It becomes an integral component of the raised access floor. And that is really used as a metering device to meter air from the pressurized plenum into the occupied space.
Every person in each of their workstations has their own Kronz diffuser. They can adjust the amount of air entering their space, therefore mitigating the single most heard complaint in American buildings, and that is I'm either too hot or I'm too cold. The next thing is, since you're not having diffusers in the ceiling, you can now use an indirect lighting system. Bounce light off the ceiling and back down to the work surface. What that immediately does is it entirely eliminates glare on computer screens because you don't have any direct hot light source.
On a study that was taken a couple years ago, the number 2 concern over workers today in the workplace was the quality of lighting. Our product on a per square foot basis is marginally more expensive than a traditional method of lighting a space. So that's a critical part of the equation, is to reduce the labor involved in the installation and as well provide energy savings and in addition reduce maintenance.
We are working with Armstrong World Industries, and they have a very new ceiling tile product out, so we're getting actually a 90% reflectance off the ceiling tile as opposed to the traditional 80%. So you increase the reflection of the ceiling, you can reduce, again, the wattage of the lighting that's put in there.
We were trying to solve more than just one problem. We wanted to be durable, so we had sustainable design. 79% of that product is from recycled materials. Mineral fiber being the most prevalent, and mineral fiber is the waste from the steelmaking process. Reclaimed newspaper, might be even your phone book. Then we have starch, which is a binder, perlite, and then clay. And those together form a mineral fiber ceiling that has acoustic properties, fire-rated properties, and light reflectance properties.
The flexibility that the underfloor air system and modular wiring system allow is that in-house engineers and maintenance people can change the office and workspace very easily. That cost maybe around $70 a workstation, whereas a traditional office space can cost as high as $300 a move.
Pennsylvania has been one of the leaders in terms of recycling and these types of things in the country. And we've done an awful lot of good things in terms of cutting down on the amount of stuff going to landfills. Paying attention to carpeting so that you don't wind up landfilling it when you're done. These are all common sense kinds of things, but things that we don't think about every day in many cases or haven't always thought about every day.
Today, we're the largest producer in the world of carpet tiles. Broadloom carpets, textiles, chemicals, architectural flooring, all of those focused on this commercial marketplace. In 1994, our customers were asking us what we were doing about the environment, what we were doing to help the environment, and we didn't have good answers. Really, my company, I, were part of the problem. I decided that we should try to lead the whole industrial world in this effort to begin to move towards more sustainable business practices.
Over the last 4 years, we have reduced the amount going to landfill by 75%. In other words, 1/4 of what we used to send per square yard is what we send today.
Some point in the future, we will be harvesting yesteryear's carpet and bringing it back into our factories and recapturing the molecules that were put into that carpet when it was made. If we can get it right, close the loop with the materials, then we'll never have to take another drop of oil from the earth. And that really does epitomize this vision that we have for our company.
The current recycling rate of PET soda bottles is about 25%. Wellman recycles about 2.5 billion bottles here in the United States alone. Starting with a bottle that is a recycled bottle put in a recycling bin by a consumer, and it goes through a rather exacting, state-of-the-art process which ends up yielding a polyester fiber.
We started on recycled about 3 or 4 years ago because it's the right thing to do. The material comes into us in bales of very short little pieces of polyester fiber. We put it through a series of processes that open it up, combs it out, spins it, twists it into yarn. From there it goes onto a loom, and then we piece dye everything into the color that the customers specify. The new addition we put on the plant last year is day-lit. During the day when the sun's out, there's no lights on in that building. We installed a new dye machine that uses about 40% less water than we used previously. Everything that we do now is looking towards the reduction of use of non-renewable resources.
The panel is made up of a gypsum core that is put into a metal welded frame that is later baked to take out about 85% of that water content. We apply the 100% recycled fabric, and from that point the hardware will be applied. Our role in supporting this intelligent building is that our furniture allows for the greatest amount of flexibility. It does that in a very environmentally friendly approach because the product that we use in our panel is 100% biodegradable.
On south-facing windows, the light shelves create about 4-foot projections, which, when the sun is high in the summer in the northern hemisphere where this building is located, casts a shadow on the glass, which minimizes the solar radiation. But there's another step taken. We actually raise the window above the light shelf as well, so that the sun's light bounces off the top of the shelf through the glass, now off this high reflective ceiling tile that we've talked about, and allows natural light to penetrate deeper into the building.
Energy-saving products actually provide paybacks. What we're using in the DEP building is a combination of 2 types of products. One of them is a power strip that has a sensor that's actually controlling loads connected to the power strip. And it would turn on and off your monitor, your task lights, and other electrical loads that are plugged into the power strip. We are also using sensors in ceiling-mounted applications in the conference rooms and in the restrooms to turn on and off lighting. The average savings for occupancy sensors for lighting control would be between 1 and 3 years. That would be the amount of time that it takes to pay for the installed cost of the product.
I put that specifically in the middle as opposed to either side.
Well, the landscaping is the last major piece that needs to be finished.
To keep it even.
Starting in the front.
So we decided to get a group of the employees together, those who were interested, and we didn't limit it in any way. Anybody who had some interest could come and participate in the landscaping.
We've talked about how we can significantly reduce energy consumption in a building by approaching it from a green standpoint. We've talked about the use of materials that are sustainable. One of the wonderful, wonderful and primary impetuses behind this whole approach is we can create more friendly environments for occupants of buildings. The paints that are used, the adhesives that are used are selected to minimize any volatile organic compounds. Any off-gassing that occurs in a typical building, which could last as long as a year, is eliminated.
The paint on this building is a product called Polymix. The product is low in VOCs, which means it's environmentally friendly. The product has been designed to give a long life meaning 10, 15 or more years. It's not only friendly to the environment, but it's friendly visually to the people that are working in the environment.
I think this is just wonderful. This whole green technology, I mean, we are the Department of Environmental Protection. If anybody's going to do it, I think we're the right people. Isolated ground.
What I like to think of as environmental design is fusing
the environmentalist's thinking with the architect's thinking. So you aren't just designing for the environment around you, you're designing for the whole environment. The really exciting thing is that there are all these really great products available.
Really what this represents is kind of a merger of looking at agricultural materials as a renewable resource and recycled materials and then engineering them into new and exciting products. The Department of Environmental Protection uses a blend of technologies and materials. It uses what we call a wheat composite panel, where you use natural wheat with no formaldehyde, and we make it into a real nice biofiber decorative tile, which is very strong, very durable. The tiles also that go with it as accent are our Environ, which is really derived from a natural water-based soybean resin. And then also we use the Wall Street Journal as a cellulose fiber that reinforces the composite. So a lot of people like to say it's soybeans and newspaper, but it really represents a very new technology.
The company is in the business of manufacturing recycled glass tile. We use windshield glass, plate glass, and industrial type glass. Glass has a different characteristic than any other product out on the market. It's a highly commercial rated tile, and a lot of places when they want to put in tile, they want something that's going to last. And glass is very strong, it's very durable, and it wears a long, long time.
We see this as a wave of the future. We see that brownfield sites will be a wave of the future. We think green building technology will do the same thing.
None of this is rocket science. It's actually pretty much common sense. It's about making buildings smarter.
The real benefit is going to come in those Pennsylvania taxpayer dollars are now having a higher return because the people that work there are healthier, they're absent less, and they're doing a better job. Their productivity goes up, and that gives a direct return to the taxpayer.
I think employee morale is really going to be increased with practically everything new, as well as it being a green building. And because we are environmentalists, it's going to be thrilling to be in that kind of atmosphere.
This is a wonderful model, not so much because it's state government, but because it's right there in front of everyone.
I think the time for green buildings has come. The fact that the government has taken a role or lead in this kind of activity will soon drive it down into other arenas.
It's made a profound set of impacts on me as an individual in terms of what I'm going to be doing career-wise and work-wise in some of these things, because I'm in the right place right now to really be pushing at it, and we're going to. We've already opened another set of proposals for a green building, another one.
Key was a team approach to this unique and precedent-setting facility, environmental protections, South Central Regional Office Building.
The fact is, leadership does come from real government, and I think we have a leadership role to show private sector people that they're on the right track when they're doing this, or if they're not, maybe this is a track they ought to think about for their own economic and competitive efficiency and for the greenness of the Commonwealth.